Hello, welcome back to ReddyControls. In this video, we're going to talk something detail about some of the fundamentals of understanding ladder logic. In my last couple of months, I had questions from some of the viewers where they're struggling to understand the basics of how the ladder diagram works. So in this, we're going to talk about what an instruction is, what a branch is, what a rung in condition is and rung out condition is, and how do we choose the required instructions and how do we arrange the input instructions and output instructions. So without getting delayed, let's get started into the video. So we're going to talk about what a ladder diagram looks like. So what you're seeing on my screen is a ladder diagram, and it looks like a ladder with steps. So each one of this is a rung. So I have 17th rung, 18th rung, and I'll go insert a new rung. You could either click that or insert one, right? You can have the rung has two basic types of instructions, right? And one is a input instruction that checks, compares and examines specific condition based on your machine process. So for example, this examine on instruction, examine off instruction, these are all your input instructions, right? At the basic fundamental levels, right? These input instructions, they check, they compare or examine specific conditions on your machine. So for example, these are input, and you might have logical operators which are also work as input. Like logical operators would be computer math, where you are comparing something like an equal to statement, a not equal to statement, less than, greater than or equal instruction. We'll go through each of these instructions in this video to get a better understanding of how these work. So these are all called as input instructions, right? And as you can see, I have errors because I have no tags defined. So I'll just go ahead and remove all these compare ones. But you have three input instructions. So a rung has two types of instructions. One is input instructions, which check for conditions, compares and examines a specific condition. And then it has output instructions, which is a ODE or a output unlatch or an output latch. So these three are called as input instructions. These three are called as output instructions. So input instructions and output instructions. And then next set, I'll just put one more rung to talk about what's called as a branch. A branch in a rung has two or more instructions in parallel. For example, I'll take one input instruction and I want to put one more instruction in branch. To do that, we go ahead and do add on this branch. We could select that branch, then where the green arrow is, and then pull it back. So I'll do it one more time. So we do go into add on branch, and wherever you see the green dot is where you drop using the left click and let go of the left click. And now to move this behind this instruction, you just select that, left click, hold it, and then drop it on the green dot. So now you made one branch. From here, if you want to make more branches, you could use this one, which gives a new branch level. And now this is called main branch, branch 1, branch 2. All of these are called as branches. Now I can go back and put input instruction here. So now all these three instructions are in parallel. They are in parallel. That means if any one of them is true, the output here will be true. Okay. Similarly for outputs also, output instructions, you could have a branch. Same thing, we insert it. You could insert here and then pull it down by left click, drag left click until you see the next green one and drop it. Now I can put one more output instruction. So we have parallel output instructions. And again, this is a branch. And next we're going to do one more rung, which has, so there is no limit to number of parallel branches you could enter. So we'll do one more modification. So I have one input instructions. You could have just Control C, put your cursor there, Control V. You could keep adding branches. So Control C this one. So this is the main branch, and then I have branch 1, branch 2, branch 3, 4, branch 5. Total there are 1, 2, 3, 4, 5, 6 levels with main branch, and then branch 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is one more variation of how you could organize your ladder. It all depends on what kind of conditions you have in your logic. The other thing, you could do nested branches. Nested branch looks like this. So we just put one input instruction, which is examine on, one input instruction, and then I can have one output instruction, but now I can have a nested branch. So I have one branch, right? But on this branch again, I want to use input condition, and if that input condition is true, I want to make one more output condition. Again, I can build one more nested branch around the output instruction like this, and then put one more condition for input and then an output. And I can build one more branch around one more nested branch, I can put one more nested branch right there, and then put one more condition, and then one more. So you could see I have 1, 2, 3 nested branch and one main branch. I'll delete that one. So this is a nested branch. You could nest up to as many as 6 levels. That means you could have one here and then 1, 2, and you could keep nesting like up to 6. One more nested branch, and I can do one more, 4, 5, and I can have one more nested branch. So that's how nested branch works. So this is nested branching. The max is 6 levels. So 1, 2, 3, 4, 5, 6 levels. Large rungs with complex nested branches resulting for us to keep scrolling up and down to see the logic, and also when we print it, it might span multiple pages when you print the logic. To make it easier, we need to divide the logic into multiple small rungs, which is a lot more easy to understand. The next concept we're going to talk about is something called a rung condition. So for example, I just have, let's insert one rung. I have one input instruction, and then I have one output instruction. The condition after the controller evaluates ladder instructions based on rung conditions preceding the instruction. So this is an instruction. The condition preceding to the instruction, that is to the left of the instruction, is called as the Rung In Condition. And the condition after the instruction is called as the Rung Out Condition. So anything to the left of this instruction is called as Rung In Condition. Right of it is called as a Rung Out Condition because the ladder flows left to right. If the Rung In Condition to an input instruction is true, if Rung In Condition is true, the controller then evaluates this instruction. And if the instruction is true, then it will set the Rung Out Condition, which is right side of that instruction, is true. And then same thing applies to this output instruction. Since the Rung In Condition is true, it will evaluate the output instruction and process the output instruction and sets the Rung Out Condition to true. So it's easy to explain with an example here. So we'll just delete all this, and so we'll put a new rung, and we'll just put one instruction. We just call it input instruction. We'll just define a new tag called input instruction, and it's a base tag and it's a boolean. So we say create, and then we create a output instruction. We call it new tag output instruction and create put underscore instruction. So I'll go ahead and assemble that rung using the finalize all edits. I have no errors, so it's all good. So since the Rung In Condition, see this Rung In Condition is true, the PLC is trying to execute this instruction, and this instruction is examine, right? So if it's on, then the Rung Out Condition, which is right here to the right side of the instruction, will be true. And since the Rung Out Condition is true, it will go ahead and process this output instruction because output instructions just process the output. So to do that, I will toggle this bit, and that bit is true, your output instruction came on. So in here what we are seeing is the rung in condition to this input instruction is true, and the rung out, and since examine if on is the instruction and this instruction is on because we toggled it to 1, the output condition, rung out condition came on, which made this output instruction on. Okay, just to make it easy to understand, I will put in one more instruction. I'll just call it input instruction 2. Okay, just call it 2. So the moment I assemble this instruction, to show it, I will go ahead and do accept it and then do a small test so we can see how it operates, and hit the test edits. So you could see immediately the output instruction is off, because even though my rung out condition is true here, I have a rung in condition true, but this instruction itself is not true because its value is 0, and we are looking for examine condition, examine on, so it needs to be a 1 for it to go through that. So rung out condition true, rung in condition is true, but the instruction itself is false, so the output instruction is not on. So it's an important concept to understand what a rung in condition is and a rung out condition is. And we'll go ahead and assemble this and see my rung in condition true, instruction is true, rung out condition is true, but the rung out condition of instruction 1 is true, rung in condition of instruction 2 is true, but the instruction 2 itself is not true, so it won't execute. So I'll go ahead and toggle this bit, and now my rung out condition output instruction becomes on. So this is a series instruction. Now I can put demo others 3. So you can see 3 instructions are true, so this is a series instruction. So now we'll do a similar instruction to show the difference between a series and parallel. What we're going to do is put branches and control X this slowly, and put one more branch using branch level and control X slowly. And we'll just use a different instruction 2, output instruction 2, and we just call it 2. So now you can see output instruction is not on because it's waiting for all these 3 conditions to be true for that to be true. So this is a series connection. It's like an AND. Input instruction true, and input instruction 2 is true, and 3 is true, makes output instruction true. This one is a OR branch. Input instruction is true, a condition 1 is true, or if any one of these 3 conditions is true, instruction 2 is going to be true. So I'm going to toggle this bit off. I still have that on. But once I toggle input instruction off, output instruction 2 is off. So this is parallel and this is series. And we can also do something called as a series and branch condition, where I just control X this guy and do control V. So now I have a different condition. I need to have, if either one of these conditions is true, either this is true, so this is called a combination. So if either of these is true and this is true, that's when the output becomes on. So I will make that true by Control T toggling that one, and then output instruction 3 won't come on because I'm waiting on this condition. Even though my input condition is rung in condition is true, since the instruction itself is false, my rung out won't be true. So output instruction 3 won't be true. I will let now one of them not true. So let's do it. The last instruction on a rung must be a output instruction. What does that mean? So let's see. Put that one. Say I use the same one. If you want to copy paste it, the names, right? You could always drag and drop and show you that. See? So I want to copy paste. You just click on the name. See how you dragged it, and drop it there. So I can have out 4. Create a new one called output instruction 4, and I can add a branch after that. Add an input instruction called input 3 there, and I try to assemble that rung. It will give me an error because it's missing an output instruction. So it's waiting the rung is looking for an end of a rung to be an output instruction. So if I put 1 there and call it out 4 or 5, now my error is gone. The error is removed. See? Seen people do multiple outputs in one rung, which makes it very hard to troubleshoot or follow, but I have seen people do multiple outputs with multiple conditions in one rung, and I have seen people do input 3 output and then put 1 more and put branches like this, double branches like that, and then they would put triple branches, and then they would put a output 6 there. We call it a new output 6 here, and you can use, some people do this. So on this one, very interesting, right? So I have my rung in condition true, rung out condition true, and this condition is true. Since this output is rung out condition is true, it will execute this instruction. What if I toggle that low? See, everything turned off. Because if by now if you understood the rung in and rung out condition, you'll understand logic a lot easy, because my rung in condition is true for this input instruction, and the input instruction itself is true because it's examined on. And then rung out of this one is true, and rung in of out 4 is true, so output 4 came on. Rung out condition of output 4 is true, and this instruction is true for examine on, that's why it came on green. And rung out condition of input instruction 3 is true, so that's why output 5 came on. Rung out condition of output 5 is true, and then one of this branch, and the rung in condition for all these 3 is true, but since this instruction is true, it executed this and came out. So if I just toggle this guy off, you could see the branch just stopped till here because this input instruction is blocking everything. Now if I replace this one, so that's how rung in conditions and rung out conditions work. Hope you understood what a rung in condition and rung out condition is. In the next set of video, we will talk more about the compare instructions. Thank you.